Today we're going to be talking about normal distributions. A normal distribution is a symmetric, single-peaked, and bell-shaped distribution that's completely determined by its mean and standard deviation, which will denote the mean by mu and the standard deviation by sigma. These are also known as the population mean and population standard deviation. So below you'll see a histogram, and what we can do with this histogram is actually approximate it with this nice little curve. And this is a smooth curve, supposedly. Okay. And this is supposed to be single-peaked and bell-shaped, which you can obviously see that it is. And we need it completely determined by its mean and standard deviation. What do we mean by that? So in this case, we actually have mu equal to 100. And our sigma value actually equals 10. And you can see, here's the 100 value right up there. And don't let your eyes fool you, that's a straight line on up. And then we can do the same thing for every standard deviation of 10. We can kind of move on over. So one standard deviation to the left would be 90. That's appearing right here. And one standard deviation to the right. Once again, don't let your eyes fool you, that's my best attempt at a straight line. So that's 110. Moving two standard deviations to the left would be 80. Two standard deviations to the right would be 120 because you get 2 times 10. And then so on and so forth. You get this 70 would be 3 standard deviations to the left, and 3 standard deviations to the right would be the 130. So technically what happens with all these, we have our mu sitting right there in the center, and so the 110 is just, let's draw this on down just a little bit. You get within 1 standard deviation, so you subtract sigma. On the right hand side you just add sigma. So this is another way to write 110. 120, that would be mu plus, we have, so 2 times 10, so an easier way for us to write that is 2 sigma, and the 80 would be just mu minus 2 sigma. Same thing with the 130, this would be mu plus, well, notice we said we were 3 standard deviations away. Nice shorthand notation is 3 sigma there. And then same thing for the 70, it'd be mu, except it's minus since we're going to the left. And in general, what can happen is if you have any given standard deviation, say something like this right here, and we have this bell-shaped curve. Okay, in general, you have some center point, which is given by exactly what we wrote over there. It should be mu in general. Okay, and you can go 1 standard deviation to the left, and that would be just our mu minus sigma. I'll draw that right on down there. 1 standard deviation to the right. Notice what I'm actually attempting to do here, even though it might not look like it, is draw that out where they're equally spaced on either side. And so every so many units, we're going to have a new spacing. So you have mu minus 2 sigma over here. That would be 2 standard deviations to the left. Same thing over here, assuming it's equal spacing. Mu plus 2 sigma. And then we can get our mu plus 3 sigma at that position. And then mu minus 3 sigma at this corresponding position. So what's the big deal with this mu plus or minus so many sigmas? Well, actually, the big deal is it tells us a range, or percent of individuals falling within this range. And what do we mean by that? Well, within 1 standard deviation, you can see right here, we've kind of drawn a line on up. There's 68% approximately, so this is an approximate value. 68% of the data values fall within that range of 1 standard deviation. And so you might say, well, that's not so useful. Until you go to individuals, let's say we had individuals in our graph here. So our histogram, what that tells us is we have 68% of the individuals approximately being between 90 and 110 on our graph. And where do we get the 90 and 110? We got them from right down below, so you see me circling that on the x-axis. And we can go for within 2 standard deviations. That's obviously going to enclose a few more people because we're getting further out away from the mean. But this actually makes a big jump. So we go to 95% of the data values fall within that range. And so if we just take this and erase here, we have now within 2 standard deviations, which is from 80 to our 120 mark, you have approximately 95% of the values. So the 80 and the 120, notice that appeared. Here's your 80, and here's your 120 right there. Okay. And last but certainly not least, for 3 standard deviations, how much of the data values are going to fall within that range? Well, that's approximately 99.7%. And this idea right here is actually the empirical rule, right? And this is basically saying we have within 1 standard deviation, there should be about 68%, 2 standard deviations, there's 95%, and 3 standard deviations, there should be 99.7% of the individuals from our data set being within that range. And so relating that back to our problem here, if we look within our 3 standard deviation marks, that would be from 70 to 130, we have 99.7% of those data values fall within that range. So the 70, which we'll enclose with a triangle here, and the 130 right down below. So keep that in mind with the empirical rule. We can actually start to use this and figure out percentage of people, or if you're doing stock prices or whatever the case may be, if you have some sort of normal distribution, you can start making calculations on those percentages. And that's the whole idea, what we're trying to gun for with this normal distribution.